Hello everybody, hope you are doing well. Welcome again to Economic and Research channel. I'm Dr. Abdul Haq Sinachki, and today I would like to share with you panel data analysis using Eviews. So we are going to do a simple OLS regression, fixed effect model, random effect model, and Hausman test. So what is panel data or longitudinal data? We have a pool data where it is occurred when we have a time series of cross-section, but the observation in each cross-section do not necessarily refer to the same unity. So you may have several times you collect the data, but not the same respondent or not the same companies. But the panel data refers a samples of the same cross-sectional units observed at a multiple point in time. That means you collect the data, let's say a survey, then after 6 months you go to the same people, another 6 months you go to the same people, and it's like that. A panel data observation has two dimensions, XIT, where I runs from 1 to n and denotes the cross-sectional, could be person, company, country, and T runs from 1 to T and denotes the time of observation, could be 10 years, 20 years, 50 years, 5 years. So we have two types. We have a balanced panel data that has every observation from 1 to n observable in every period 1 to t. Means we have a complete set of data. Nothing is missing. And we have an unbalanced panel data which has a missing data. General linear model is the foundation of linear panel model estimation. We have three types. First, ordinary least square OLS, weighted least square WLS, and generalized least square GLS. So what is the fixed effect? The fixed effect explores the relationship between predictor and outcome variables within an entity, could be country, person, company. Each entity has its own individual characteristics that may or may not influence the predictor variables. For example, being a male or female could influence the opinion toward certain issues, or the political system of a particular country could have some effect on trade or GDP, or the business practices of a company may influence its stock price. So when using fixed effect, we assume that something within the individual may impact or bias the predictor or outcome variable, and we need to control for this. This is the rationale behind the assumption of correlation between entities' error term and predictor variables. So the fixed effect removes the effect of those time invariant characteristics, so we can assess the net effect of the predictors on the outcome variable. And also another important assumption of the fixed effect model is that those time invariant characteristics are unique to the individual and should not be correlated with other individual characteristics. Each entity is different, therefore the entity error term and the constant which captures individual characteristics should not be correlated with the others. If the error terms are correlated, then the fixed effect is now suitable, since inferences may not be correct and you need to model that relationship, probably using random effect. This is the main rationale for the Hausman test. We will talk about it later. The random effect, the rationale behind random effect model is that unlike fixed effects model, the variation across entities is assumed to be random and uncontrolled and correlated with the predictor or independent variables included in the model. So the crucial distinction between fixed and random effect is whether an observed individual effect embodies elements that are correlated with the regression in the model, not whether these effects are stochastic or not. If you have reason to believe that differences across entities have some influence on your dependent variable, then you should use random effect. An advantage of random effect is that you can include time invariant variables, example gender. In the fixed effects model, these variables are absorbed by the intercept. Random effect assumes that the entity error terms is not correlated with the predictors, which allows for time invariant variables to play a role as explanatory variable. In random effects, you need to specify those individual characteristics that may or may not influence the predictive variables. The problem with this is that some variables may not be available, therefore leading to omitted variables bias in the model. Random effect allows to generalize the inferences beyond the sample used in the model. So now we are coming to the point where what to choose, fixed effect or random effect. To decide between fixed or random effect, you can run a Hausman test where the null hypothesis is that the preferred model is a random effect versus the alternative one, the fixed effect is the most appropriate. It is basically tests whether the unique errors UI are correlated with the regressors. The null hypothesis is they are not. So now we go to the Eviews, and I have data set for 15 countries here, and times from 1980 to 2014. The variables are GDP per capita, CO2 emission, metric ton per capita, and trade as a percentage of GDP, and export as the current USD. So I want to see now in the model how export, trade, and CO2 emission affect the GDP in these 15 countries. So I go to Eviews, File, New, Work File, and I choose panel data, balance panel data. So my data is annual, so from 1980 to 2014, and here we have 15 countries. So I put OK. I import my data, import, file, then we select the data. So I would like to make the natural logarithm for CO2 emission and export and GDP. For trade, I will not because it is already in percentage. So ln CO2 emission equal log CO2. Then I have ln GDP equal log GDP. Then I have ln GDP equal to log GDP. Then I have ln export equal log exports. Now I will click first on ln GDP, then control, then I put ln CO2, ln export, and trade. Open as equation. Okay, then I put okay. So I got the result, a simple OLS regression. Okay, now we can see here from the data, CO2 emission has significant impact on GDP and positive. Export has a significant impact, but it is negative. The more we export, the less GDP. It doesn't make sense. And trade has also a negative impact and significant at 10%. So I doubt that this model is correct. So I go and check now the fixed effect. I will put same model, estimate, panel option, and here in the cross section I will change it from none to fixed and click OK. Now you can see the model is much better corrected. We have all the variables are significant at 5% and all of them positive, which is makes sense and confirm the theory. But what about the random effect? Which one? Is it the fixed effect or random effect appropriate in that case? So again, I will go to estimate, panel option, and again I change back this from fixed to random and press OK. Okay, random effect also gives similar result. All the variables are significant at 5% and positive sign. So now I will come to decide which one I'm going to use. Is it the random or the fixed? I will keep here in the random. Then the null hypothesis, the random effect is the most appropriate, and the alternative is the fixed effect is more appropriate. So if my p-value comes below 0.05, therefore I reject the null hypothesis and accept the alternative one, which says that fixed effect is the most appropriate. If the p-value is more than 0.05, therefore I cannot reject the null hypothesis, I have to accept it, and therefore the random effect is the most appropriate. So let's go and see, view, fixed random effect testing, and I come here, correlated random effect Hausman test, and the probability of the chi-square is 0.000, which is less than 0.05. Therefore here I can reject the null hypothesis that says the random effect is most appropriate, and I will accept the alternative hypothesis that says that the fixed effect is the most appropriate. Therefore I go back to estimate option and change back this to fixed and click OK, and this will be my model. So you can see that 1% increase in CO2 emission lead GDP to increase by 0.30%, and 1% increase in export led GDP to increase by 0.01% is marginal, and also 1% increase in trade led also GDP to increase by 0.004%, which is also marginal effect. So most of the effect comes from the CO2 emission, and therefore means that these countries mostly based on industry or industrial production. So that more they produce for the GDP, the more they pollute. And let me see if the model is significant. That is very important. Yes, statistic probability is 0.00. So therefore here I hope that you understand this simple concept of panel data and fixed and random effect and Hausman test, and I will or we will discuss in the next video more about other options of panel data. So I will see you soon. If you have any comment, you can write your doubt or your questions in the comment below the video, and I try my best as soon as possible as I can also to reply you. Thank you very much.